In this video, we're going to continue with exponents, but we're going to look at what negative exponents mean and how they work. So let's go back to an example I'm going to write on here that's not actually on your notes. If we had x to the fifth over x squared, in another video, you learned that that would be x to the 5 minus 2 or x cubed. And I said to you, think of it as 1, 2, 3, 4, 5 x's over 2 x's, 2 cross cancel, you're left with 3 in the numerator. But what if you have more in the denominator than you do in the numerator? So if we look at this example, we would have 2 in the numerator, we would have 1, 2, 3, 4, 5 in the denominator. 2 of them still cross cancel. You're still left with 3, but look where they are. They're no longer in that numerator. And what's left up here? The implied 1. So what we have is 1 over x cubed. Now, what does that have to do with negative exponents? Because if I do this a different way and I use my quotient rule, it would be x to the 2 minus 5. It's always numerator minus denominator exponent, which is x to the negative 3. So x to the negative 3 is the same thing as 1 over x to the positive 3. Negative exponents do not mean negative numbers, they mean reciprocals. So it's another meaning of a negative sign. So here is our generalization. If a is a real number other than 0 and n is an integer, then a to the negative n means 1 over a to the positive n, because that's the reciprocal, and 1 over a to the negative n means a to the positive n over 1, because that's the reciprocal, which is a to the positive n. So you just have to learn that a negative reciprocal means the exponent. An easier way to think about it, a kindergarten way, is that a negative exponent means the base is not happy where it is and it has to change locations. Excuse me. So this base was in the numerator, it moved to the denominator and became positive again. This base was in the denominator, unhappy, it was negative, so it moved to the numerator and became positive again. So this means 1 over x cubed, and this means x cubed over 1, or just x cubed. So let's try a couple. It can be tricky. This means 1 over 3 squared, or 1 over 9. Let me write this over on this side. It does not mean negative 9. It has nothing to do with a negative number. It means reciprocal. This one you have to be careful. The negative 3 only belongs to the x, so the x is the only one moving. The 2 is perfectly happy. It is raised to the first power. It has a positive. It's happy where it is. So 2 over x cubed. Only the negative one moves and becomes positive. Tricky here. This becomes 1 over 2 to the positive 1 plus 1 over 4 to the positive 1. But now I'm adding fractions with unlike denominators, so I have to find an LCD, which is 4. So I've got 2 fourths plus 1/4 is 3/4. Again, remembering that negative exponents mean reciprocals. Here, the negative belongs to everything in parentheses, so I take its reciprocal, I move it to make it happy, and now we are going to do the multiplication. So it's negative 2 times negative 2 times negative 2 times negative 2, which is positive 16. Here the 5 is unhappy, so it's going to come up and become happy. Multiply it out, and you get 25. Here the y is unhappy, so it's going to come up and become happy. And it's over 1, but it doesn't really matter. All right, let's look at a little bit harder ones. These are ones that have parentheses, and we have to do a lot of moving. Couple ways to think of this one. You can think of it as the 2 is to the negative 3. The x is to the negative 3. The 2 is unhappy. It comes to the denominator and becomes positive. the x is unhappy, it comes to the numerator and becomes positive, and you end up with x cubed over 8. Or you can think of the negative exponent means the reciprocal, so it should be x over 2 to the positive 3. But that still takes you to here and gets the same answer. Here, be careful. This is the only one that's negative. This one is positive. It stays where it is. This negative one right here comes up and joins that one. And now what do? I now apply the product rule. So I end up with y cubed. So you really have to know how these rules work. Here, this one's unhappy. This one is also unhappy. Can I apply the quotient rule here and subtract the exponents? No, because my bases are not the same. One's a Q and one's a P. So that's all you can do. Tricky one. This one's happy. It stays where it is. This one is unhappy. It comes down and joins it. What is that equal to? It is not equal to x12. It's equal to 1 over x to the 12th. And there is a difference. So when this moves, the only thing that remains is its implied coefficient of 1. So be careful. If you said x to the 12th, that's not right. It's 1 over x to the 12th. Let's do a quick review of the rules, both positive and negative, that we've had so far. I have them written here. We'll complete them and then we'll do some number examples. So on this first one, product rule. 2 bases being multiplied, you keep the base, you add the exponents. So for example, 2 cubed times 2 squared is 2 to the 5th power. Power rule, you have one base inside-outside exponents, you multiply them. So 2 cubed being squared is 2 to the 6th. Notice I'm not multiplying these out. I'm just applying the rule. Little variations on the power rule. If I have more than one factor in parentheses, then the exponent goes to both. So if I have 2x being cubed, 2 gets cubed and x gets cubed. Here it's a to the n over c to the n. So if I had 2 over x being cubed, it's still 2 cubed over x cubed. It applies to everything. Quotient rule. If I have like bases in division, I subtract the exponents. So 2 to the 5th over 2 squared is 2 to the 5 minus 2, or 2 cubed. Anything to the 0 power is 1. So if I have 4xyz to the 0, it's still equal to 1. And finally, the one that causes the most confusion, a negative exponent means the reciprocal of that positive. So 2 to the negative 3 is 1 over 2 to the positive 3rd power.